Good evening, everyone. So this is today we are here for the webinar Mathematical Modeling to Real World Application. Webinar is organized by DG Saksham. So we would like to extend a special welcome to our guest, Mr. Nitendra Kumar, who will be guiding us today. So,
Thank you.
who are the organizers? So, SEMS Welfare Foundation has organized this, but it is a non-profit entity established to work in the areas of education, social welfare, women empowerment, skill development, and entrepreneurship. They also work in livelihood generation and employability, health research, culture, international cooperation, sports, environment protection, and many more sectors. SEMS Group has conducted various international conferences, seminars, workshops, and webinars in emerging technologies in various parts of India and has an active network of 3,000 plus engineers, managers, researchers, and industrialists. DG Saksham is another initiative of SIMS Welfare Foundation and has developed content for over 300 courses in multiple languages, which range from 4 hours to 6 months in various sectors of IT, BFSI, retail, entrepreneurship for all age groups, from school children, youth professionals, and senior citizens with over 6,000 training till date. So now moving on to our today's event. Today we are going to discuss some mathematical modeling. Mathematical modeling, we take a real world problem and write it as an equivalent mathematical problem. We then solve the mathematical problem and interpret its solution in terms of the real world problem. So after this, we see that to what extent the solution is valid in the constraint of the real world problem. So on this topic, we will be guided by, as I mentioned earlier, Dr. Nitendra Kumar. He has did his PhD in applied mathematics on the topic matrix techniques in data mining. Dr. Kumar has expertise in several teaching and research-based mathematical and statistical softwares such as MATLAB, Mathematica, AWeaves, e-education teaching technology, GeoGebra, Autograph, and many more. He has more than 8 years of teaching, research, and industrial experience in the field of mathematics and statistics as well. Dr. Kumar has earned international certification from Dell, Carnegie Associates in high impact teaching skills. He also been working relentlessly to achieve his vision to educate, perpetuate, and enrich the students with the knowledge of mathematics, irrespective of their background, and making India a world guru in mathematics. So I request to Mr. Nitendra Kumar to address us more on this topic. Mr. Kumar.
Thank you, Divya, and also thank you so much for organizing such type of webinars, not in only mathematics, also in the other fields, especially SEMS Foundation. So, as of today's topic, mathematical modeling to real world applications. So, before starting this lecture, I want to say thank to all the participants who are attending this webinar. So basically, the topic of today's lecture is mathematical modeling to real world application. So as we know, mathematics is not a small area. Mathematics is everywhere. So herein, I have selected one of the topic is wavelet methods. So the specialty, or we can say the beauty of this techniques applied in the data mining. So in this 21st century, everywhere we can say all the things are using by the computational methods. So this century is basically very important for the data scientist. So myself, Dr. Nitendra Kumar. So in next 50 minutes, we are discussing some techniques related to the wavelet methods directly related to the data mining. So before starting this lecture, what is the data mining? So I will brief the concept of data mining. So in this century, how we can say the initiation or initiated by the data mining. So what is the basically the history? So some references I quote here, like in 2002, Benoit, this one, data mining. So if we read the chapter 6, so some history about the data mining is given. So basically, we can say in a general way, data mining is a multi-stage process of extracting previously unanticipated knowledge from the large data set and apply for the result for the decision making. Some people refer the term knowledge in database. So if we read some other references, then we can say some of the researchers uh, told about this topic, one this knowledge in the database, KDDD. So but after some time, the very famous topic is the data mining. Also, this field we can say the adopted by or we can say developed by the first part of the mathematicians, statistician and computer sciences, mainly in the last 3 decades. If we say in the last 30 years, most of the mathematician, statistician and no doubt computer scientists are working closely. So in 1996, basically this was mentioned in 2002 paper of that this one, Manoid. Its topic is very important, and its beauty we will see in further. So it's very important. Anyway, so just a simple way how we can say the data comes from our daily life. So here just I want to brief the concept of data mining, and data comes from the different ways. So here the data are basically usually in the form of signals, images. If we are using like in biomedical fields, then we can found some signal like EEG, ECG, and for the images, brain signal. So data basically comes in terms of the signal images. So these data set arise in diverse field such as financial market. So here are some examples. How many fields are providing such types of data? So some fields like as financial markets, meteorology, medical imaging. Also we can say from the physics, those who are working in uh, materials or nanomaterials, then we can have find the several database. Also in the chemistry, material science, astronomy, bioinformatics. They can also obtain from the simulation, some experimental work, simulation work. Also we can found from these techniques. So basically the data mining is the process. So data mining is the process concerned with uncovering patterns, associations, anomalies, significant features and structures in the data. So if we can see from the data, like here the signal and images, so data comes from the different fields such as financial market, medical imaging. So we can say कि data mining is basically multidisciplinary field and it enhancing ideas from the different domains. So This process means this the data mining is process is very important in the multidisciplinary field. As in earlier PPT we have always also read, the mathematician, statistician and computer scientists are started, right? We can say apart not from these one, so we can also include the image processing, signal processing, machine learning, optimization, high performance computing. Right now we are saying supercomputing, computer retrieval and computer vision. So the data comes from the different field. So these are the some domains wherein the people are work closely in different field. So basically, it holds the promises of helping scientific community and technology in the analysis of massive complex data sets, enabling them to make reasonable decisions and discovering after gaining fundamental insights. So here the meaning of this para is the data is unstructured, right? So this unstructured data, how we find in our simpler way. So this is the hidden part. So there are several techniques to find out the feature extraction. So the beauty of this data mining techniques are we will discuss further. So how we can say the data can be divided in different or we can say the following themes. So if we can say the characteristics of different classes of data, such as data of astrophysics and astronomy, remote sensing data, bioinformatics, biological data, financial data, security and surveillance time series data, and characteristics of meteorological data. So for the different data set, they have the different characteristics. So how we can find out the actual information from this data set, right? So basically it divides in the different way. The second one, management of data. So firstly we have to find out the data, then how we can manage it. And the third one is reduction of size, or we can say dimensional reduction. So nowadays uh, data storage is also the very important problem. We can say the very big challenge for the computer scientist, how we store the data. So this is a very challenging task right now. And the fourth point is denoising. So for the denoising, if the data comes from in any field, so maybe the data having some blurred, noisy, then how we can denoise it, how can we can deblur it. So denoising also the very important task. Data compression, fusion of data, enhancement of data, pattern recognition in data clustering, classification anomaly. So basically in a statistical point of view, if you have huge data, then how you can find out the best pattern. So data clustering and classification, these are the very important techniques. And after that, extracting features in the data similarity search. So when you have the unstructured data, then how you can find the best features, right? So this is the very important task. Finding missing elements in the data, like in the denoising part, if you have data but you uh, find some missing information, then how we can find out the missing information. So this is also very big challenging. Prediction in earthquake, tsunami data. So prediction is also very important. and then visualization. So you have the data different way, then how we can visualize it. So these are the basic theme which we have divided in the data mining process. So these are some process which we can divide it in data mining techniques. So we can say how many data mining techniques. So we definitely simply we can say these are the data mining techniques. So basically, as of my experience, if I read the several I read the several papers. So apart from that papers, I found out these are some important references. Chandrika Kamath, the second one, she published a very good book on topic this one. Taoli, if we can working on data mining using wavelet methods. So Taoli published a paper in 2003. This is very important paper, and this third one. So these three papers are the very important for the beginner, those who are working in the data mining. So also we can define the definition of the data, this one, data mining: the extraction of novel, useful, and understandable patterns from the large collection of data is known as data mining, or KDD, right? So for this unstructured data, how we can find out the useful and understandable patterns? So this is the basic definition of data mining, or we can say knowledge discovery. Basically, data mining comprises data management. So for the data management, how we can data assessed, stored, and manage. This is first part. Data pre-processing, those who are working for the large data sets. So pre-processing is the very important point of view. Basically, those who are working in soft computing. So this part is very interesting. So in data pre-processing, denoising and dimension reduction. When you have the huge data, then firstly how you find out, means how you can reduce its size. So dimension reduction is important. And denoising, because if the noise in the data, so when you are working any experiment, so if you have the denoised data, then it will not provide the good result. So denoise the data, like in the EEG and ECG. So when you have the data EEG and ECG, so we can see the basic figures of EEG and ECG. So most of the cases we found the noise. Data mining task and algorithms: post processing, refining, and evaluate. So dimension reduction is a crucial pre-processing steps of data mining and enables faster execution of algorithm, reduces size of the original time series. Suppose you have huge data. So firstly, we have to find out the coefficients, means which techniques we can apply for its data reduction. Now you have some small data, then you can apply the algorithms, then we can see the algorithms becomes faster and it will be easier for the analysis of the data. Data mining task and algorithms refers to a procedure where intelligent methods are applied to extract useful information patterns. Basically, we can say for the information pattern, some techniques are important, like classification, data clustering, data regression, and content retrieval. So these are the basic and very important techniques. So we can say there are several data mining techniques applied in different way. So here in this presentation, I use wavelet methods. So I will explain briefly the beauty of wavelet methods and some application related to the real worlds. So in this slide, how the time series analysis. So because in earlier PPT, I already told in data mining process, analysis of the time series data is very challenging part. So analysis of experimental data or observed data that have been observed at different point in time is known as time series. Like during this COVID-19 pandemic, we can say like today is 20th June. Yesterday was 90th June. So if you have some past data, then how we can predict? So if you have taken the data day wise, like 19 June, 16 June, 17 June, 15 June. So this data becomes a time series data. So the study of behavior of an event represented by a time series and feature extraction of a signal or an image representing a real world application. So like I told for this epidemic time series data, so this is real world problem. Time series is a sequence of events values which occur during a period of a time. If I say like in basically in India in the month of April, really we can't imagine, the situation is very terrible. Most of the media and other social networkings are helping the people. But if we analyze the data from the other countries like Italy, France, USA. So in our country, in basically in India, then we can do something better. So in that example, we can see the time series analysis played a very important role. So this is just an example. Basically, signal is a discrete or analytic. I told just a simple example, right? So basically, signal is a discrete. Here, basically, I am saying about that signal. So signal is a discrete or analytic function of one variable, or we can say discrete function is often also called a digital signal. If we are saying about this one, then we can also say the digital signal. And image represented by a function of two variables. So for example, like EEG, so this is a one-dimensional signal. And if we talk about the MRI, right? So this MRI is the example of the image. Image is basically example of the two variable, two-dimensional. So situation where time series can occur. So this is example. So in the field of economics, so those who are working in this one financial data analysis, So financial time series data played an important role for this one, share market. So here, this is just example. In the field of economics, banking system, where one is export, stock market quotation or monthly unemployed figures or foreign exchange rates. So here we can find out the data in terms of the time way. Also, in social sciences, we find population changes time series such as birth rate time series or university school university school enrollments. So there are several situations wherein the time series can occur. Another example, like in medical sciences, we need to study time series of influenza cases during a certain period of time, blood pressure measurement traced over time of evaluating drugs used in treating hypertension. So there are several situations wherein we can see the time series data. For example, here ECG data and functional magnetic resonance, fMRI, functional magnetic resonance imaging, FRMI of brain wave time series patterns to study how the brain react to a certain stem under various experimental condition. So for this case, if we have a particular time data for 5 seconds, 10 seconds, 7 seconds, then we can analyze how the brain reacts in this certain time period. So this is also the example of the real world application in terms of time series. So in physical engineering, and we can say in environmental sciences and some other sciences, so we can come across with a lot of time series of example. So here are this one, the atmospheric boundary layer is also representing the time series data. Time series of rainfall, like in Delhi during last year pandemic situation, most of environmental scientists are focusing the pollution example given by the Delhi, because most of the area of Delhi are polluted. So but when the lockdown comes, then most of the researchers showing the data. So this data is also the time series data. Another example of time series of rainfall affecting the agriculture products and quite useful for the flood control. This is also another example. This is also another example. So there are several examples of the time series data. So in time series data analysis, these are basically the example of the real world applications. So here we can also see the another example. Time series of nuclear reactor is also another example. Time series of ultrasound and vibration is the blood flow sounds, heart sound, and rates and lung signal. Time series of global warming. So there are a lot of application in this field. Time series of speech data, time series of earthquakes, time series of explosions. So basically in last some of the slides, we have just given the several examples related to the time series modeling, right? So in next some of the PPTs, we will discuss on the denoising and feature extraction from the wavelet coefficient, for the pattern recognition task, prediction of behavior of time series, and also in the last section, we will see how the wavelet methods work in stock market pricing. So how they can use for the prediction in combination with NFIS. So NFIS is very important technique. So here we can see the comparatively result. So in next some of the slides, we will see the very interesting application and some results also included. So we can start from the denoising. So basically, what is the denoising, or we can say the noise filtering? So the what is the noise? So the basic idea is isolate noise, or we can say unwanted elements from a signal, obtain true information content in the signal. Suppose if you are doing any experiment, so maybe some noise comes out in the data. So this noise comes from the up down situation of the electricity, maybe changement in the temperature, maybe some other challenges. So noise is the unwanted element of a signal or image. It is a random error or variance of measured variable. So I will provide some example with noising and how we can denoise using wavelets. So wavelet method for denoising a signal has been found very efficient and appropriate. So basically we can say one can separate the original signal into approximation and the detail coefficient at different resolution labels and localization and operation in both spatial and frequency domain. So basically this beauty of wavelet method is, if you have the data, if you have the signal, so the signal is very low, so the speciality of wavelet is this low resolution data to change low to high, right? It means that we have this data localized in the frequency domain. So suppose as an example how the data comes from, so suppose let's observe it, means basic model for the data denoising. So here this is the just example. Let observe data y is equals to y1, y2 and y1. So here some of the data we have taken, right? Let observe data y is equals to y1, y2 and y up to y1 be a noisy realization of the signal. So suppose x is the data, x1 x2 up to, and if we open x, so signal, right? So x so on. So suppose this y means one signal, this equation y equals to x1 plus epsilon psi plus silent yi, the noise. that in this the implies. So in MATLAB tool, direct Wavelets tool is given. So if you have any Noida, then this is another way to representation and some other part. So basically here just I am providing the brief rate denoising using wavelet. So I am avoiding the process how we can denoise the signal using this MATLAB. So here just given a basic brief example, that's it. So when you are denoising the data, so you have to find out the mean square error for explaining the error. So we have minimizing this mean square error by using this formula. So when you are using wavelet method, so wavelet method is basically transform data into wavelet basis. So if you have the signal, so for example, I am explaining, if you have the signal, so signal is very low, means we can say low damage data set. So for that data using wavelet, so it changes into wavelet basis, where the large coefficient provide user rate information, while a smaller one represent noise. Means in that signal, signal have no data, but the specificity of the wavelet is this low data comes at higher data, large data coefficient, because it provides data coefficient. So we have to select only the large coefficient. Why we choose only the large coefficient? Because present is. So by modification of coefficient, a new base can be invised. Means we will avoid these. Right? When you are using in any lab, or then manner how we can the of so method and say property of wavelets, and say is technique feature. So it when it's I will in uses so basically non-static already aware of correlation regression, but slide a large, so large the also find the correlation of wavelet clear. We can say the information are good to correlate also the within for use partial very important theory. The term statement is a energy orthonormal transform. I will
Hello.
brief this. So basically, I was discussing about the properties of the wavelets. How we can say the people who are not aware with the speciality of the, or we can say the beauty of wavelets. So these are some basic points which I have already I have told. So the initial stage, most of the people who are working in Fourier transform, this one, fast Fourier transform. So in that case, I will explain later on. So again, I repeat from all the properties. So the first property is vanishing moment. How the moments are vanished, we will see in the example. The compact support, how we can when we are uh, briefing the signal in a low and higher signal, then how we can correlate with that, reduces the temporal correlation. So already I told about the this one correlation. So for the case of wavelet coefficient, we have to directly find out the correlation, right? So we can see this correlation of wavelet coefficient are much smaller than the correlation of the corresponding process. Means, as usually we studied in the statistics, the correlation, but when we have to find out the coefficient, wavelet coefficient, and find out the correlation, then that will be very effective. So similarly, this Parseval theorem is also very important for the case under orthonormal wavelet transform. So why the wavelet are the important? So when you are doing the computational work, so it will be very efficient for the computation, right? Because for the DFT requires only these types of multiplication, and FFT requires logarithmic multiplication. So these are the basic three properties which are important. Very interesting work did by Donoha and Johnson. So they provide, so here I am quoting this reference, minimum estimation via wavelet shrinkage. So in the next slide, I will explain the shrinking of the wavelets. So this part is very important for the case of the denoising. So they developed wavelet-based denoising methods called wave shrink for estimating X for the data or signal X. So it applies in several way. I told wavelet MATLAB toolbox. Directly you can find out the denoising process. So it's very effective. So how the wave shrink comparison? So basically transforming data Y to wavelet domain. The second step is shrink the empirical wavelet coefficient towards 0. Transform the shrink coefficient back to the data domain. So in this reference, as I told, Donoho studied the threshold. So when we are, for example, using the MATLAB tool, so in that tool, when you are finding out the approximation, then you have to determine the threshold. So choice of the threshold is also the very important task. So how we can choose the threshold delta? So here Donoho normally provides the delta is equals to this one. Here n is the number of data samples because the typically the true value of the standard deviation sigma of the noise is not known. So it estimated by this. So this one is the median absolute value of the finite scale wavelet coefficient. So when we are finding the denoising, so in that process we can see which one is the very finest scale. So we have to taken only that scale. So those threshold property are playing very important role. So here are just I am given, you can see the three shrinkage function, or we can say the thresholding functions. The first thresholding function is known as hard shrinkage function. Second is known as soft shrinkage function, and the third one is non-negative. So basically, when we are in the denoising process, so we have to use these three process for the shrinking. So we can apply with these three techniques and compare the results, so we can say which one will be the best. So these are basically the some example. So here we can see basically this is the original plot of the piezoelectric material PZT of the Raman spectra. So those who are in working in the piezoelectric materials, so I have taken this XRD Raman spectrum data. So here we can see the peak position of this signal at this place. We cannot define the actual smooth graph. So wavelet methods, so some technique from the wavelets. Now here we can see the peaks are very clear. We can see from this to the original graph. So this is the beauty of wavelet methods. So this is another example of the wavelet, right? So here we can see the noise is also in this part, but here we can see the normal curve is given. So these are the example for the denoising of the Raman spectra. So this is the just example for the denoising of the signal. But when you are working in image processing, so that was the that is the another part. So here another for the denoising of FRMI by wavelet method. So here some another examples are given. Then another important part is feature extraction. So in earlier part which we have studies, that was known as the denoising. The second property of data mining is feature extraction, right? So where we have to use feature extraction. So in earlier slide I told so in feature extraction the first objective is to reduce the data size. So this is the object, right? So how the wavelet can fit for the dimension reduction. So this is the very important. So here wavelet transform represents the data as a sum of prototype function. So how we can say that this wavelet transform becomes the prototype function? Let's discuss. And it has been shown that under certain condition, the transform is only related to the selective coefficients. That is the important point. When we are finding out the coefficients, so we have to check the best features. Here it is mentioned only related selected coefficient. It means that the best feature. So we have to check the best feature. So thus, similarly to denoise the retaining selective coefficient. So in that process, wavelets can achieve the dimension reduction. So the role of wavelet method is very effective in that case, because we can see the objective again to express the original data set using some smaller set of data with or without loss of information. Without loss of information means when we are in the reduction process, it means that our objective is to no information loss from the data. So here in that case, wavelet played an important role. And while the data transformation just transform original data into a wavelet domain without discarding any coefficient dimension reduction, keep only the selective wavelet coefficients. That I told, we have to find out the best features of wavelet coefficients. So in a simpler way, the dimension reduction problem is to project the n-dimensional tuples that represent the data in a k-dimensional space. So this k should be less than n, and the distances are preserved as well as possible. So based on the different choice of the wavelet coefficient, means which coefficient are the best. So that was the challenge, how we can choose the best coefficient. So when we are plotting some different types of graph, then we have to choose which one is the best. So this is the process for the dimension reduction. So I think time is also around 8. So I am just providing some comparatively results. You can see that will be better for this short presentation. Clustering is also the very important part. So here just I am providing some graphs, then we can see. So basically just I am explaining this prediction part, because this presentation will take more time, right? So here this is the real case study did in the Oman. So directly the results are given, then you have to see. And also another case study did by one of my colleague in the field of market share data. So just I am explaining, just showing, not explain, just showing the results. That will be good, and then we can finish. So objective of this presentation, because this emphasis is very important for the prediction for the financial time series data. So ANFIS is basically is known as adaptive neuro-fuzzy inference system, right? So the relation with the wavelet coefficient, the beauty of ANFIS plays provides the very good results. So here just I am showing the results. So here we can see this original graph when we are applying some techniques, right? So we can see the approximation level at A3 here. So we compare from these last three graphs to this. So this one very effective, and we can provide at least some information directly. But here we cannot define. Also, this one. So this is the daily variation of wind speed at Dehran during 1990 to 2005. So this is the daily observation of the wind speed. You can see, but when this is the variation of parameter, daily variation of parameter of Tehran. This is the daily variation of temperature. This is the daily variation of relative humidity at Tehran. So the duration is always same, 1990 to 2005, right? This is the total rain during these 15 years. This is the national time series of the temperature. Now, as I told, wavelet coefficient. So for the time series data, we can see how the data humidity can varies for Dehran. So if we compare the wavelet spectrum for the pressure of Dehran, right? So for the wavelet, spectrum of the pressure, if we can go back, this one. So this type of the data graph is given. So we cannot explain anything in here. But if we can see these two graphs in comparison of in Dairan or Aba, so we can see how the pressure are varies. This is the wavelet correlation coefficient for the Dehran and Abha. So basically these are some examples which did by one of my colleague. These are some references. Also from the this is the funded program by one of my colleague. Also my co-supervisor Professor Abul Hassan Siddiqui did this project. So just I have given some graphs of that study. Some papers are also by me. Thank you so much. If you have any question, then please ask me.
Thank you so much, sir. So we had some questions in the chat box. So I will ask one. The one question was asked was, do you think mathematical modeling will be able to predict our life in the future? That was one question.
Right, correct.
Next question was, do you think artificial intelligence will be able to replace mathematical modeling in the future?
Exactly, the very important question you asked. For this case, for mathematical modeling, because in this century, most of the things are in the form of data. So this one, AI and ML plays a very, very important role. Uh, actually, in 1 hour, how I can explain? So the question is very correct. I am already working on this field. I have published more than 3, 4 papers already. So if someone have the problem or work with me, then we can collaborate.
Yes, and one more question was, will the process mining will take the place of AI and mathematics?
Yes, 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 yes.
So,
Several mathematical techniques are there, right?
yes, sir.
Okay, thanks once again for everyone, and also Digi Saksham to provide such an wonderful opportunity to me.
Thank you so much, sir. This was really enlightening presentation, and uh, so thank you so much. You spent your precious time with us. DG Saksham would like to thank you for giving us your precious time and sharing your knowledge with us. And also thanks a lot to our audience for attending this event. And we hope you gain knowledge today. And we look forward to seeing you at the next events.